In today's video, we're going to go over the hands-on exercise of our xarray lecture. And the first thing we're going to do is import the modules that we need, which in this case would be NumPy, Pandas, and xarray, of course. So let's scroll down to the hands-on exercise. And let me zoom in a bit. There we go. So the first thing we're going to do is download the data, which in this case come from a netcdf file that has the monthly maximum air temperature from the output of climate model. So the URL is given to us, so we're using the function open data array. Now, this function works because we have a single variable in this file. If we had multiple variables, we would get an error, and in that case, we would need to use open_dataset. But in this case, if we run this, it will take a little bit, but not too long, and we should get a pointer essentially to the file because we haven't downloaded any data yet. But we see the dimensions here, we get the attributes, we get the coordinates, and the data are here as well. Not shown right now, but you can sort of see here that we've got this number of values, which are 880 times 94 times 192. All right, so let's just pick a box from that data set. So we're just going to pick something north of 40 degrees latitude, and in this case what we can do is we can say let's pick Tmax, which would be ES, and in this case we can use cell, which is probably the easiest option, and then we can say let's get from 40 to 50, and then let's get from 290 to 300. Now, the way the longitudes are here, you see that they go from 0 to 360, hence why we pick 290 to 300. Also, if we choose a latitude of 40 to 50, we have to swap them here, the north latitude to south, because that's how the grid is oriented. So if we try 40 to 50, it's going to give us an error. So the reason why we need to use 50 to 40 here is because of the orientation of the grid. And you'll see it here because it starts near 90 degrees latitude going all the way, so from north to south. All right, so now we're getting this, Tmax. Now the difference here is that you see that we get some data for Tmax. So you can see the actual temperatures, which are in degrees Kelvin, which we can see from the attributes here. And again, the reason is that here we're not downloading the data because it's a big data set relatively, and xarray purports to the lazy evaluation that we've talked about before. So depending on your version of xarray, this operation here will download the data, but if it doesn't, the one thing we can do is just run Tmax load and we'll get it. Now, the next thing we want to do is get the minimum temperature data. Now, if we click on this link here or the catalog here, we'll see that, let's search for Tmax. So you see, this is the data set we downloaded, and the corresponding data set for minimum temperature is the same, but with Tmax replaced by Tmin. So we could copy the URL and just change the variable, but there's an easier way where essentially we can say open data array, and then we'll just replace Tmax with Tmin. So the URL is essentially the same, but we only changed the Tmax for Tmin. So instead of copying and pasting, we can just do this. And then we can also select the same bounding box as before, where we can say cell lat slice 50 to 40, and then longitude slice 290 to 300, and let's see what tmin will look like. Again, it will take a little bit longer. There we go. So now we're getting the minimum temperature. So we've got our two data arrays. And in order to construct a data set from these two data arrays, as I've mentioned in class, this is equivalent to going from the series, pandas series, to pandas data frame. But here we're getting the two data arrays and combining them into one data set. Then we can just construct it by having a dictionary. Now I want to show a slightly different way of constructing the dictionary, which we haven't really talked about, but it's good to have under our belt. So instead of having the curly brace and then the quotes, if you don't want to be typing quotes, you can use the dict keyword, and with that we can just say we don't have to pass something with quotes here in the variable, and instead of colon we can use the equal sign. So let's do this, and you see now we're getting the same coordinates as before. So the dimensions are 5, 6, 8, 80, but now we're getting two data variables. So let's name this. Let's name it data. And let's look at it again. There we go. And again, we're copying the tmax tmin with their dimensions and their coordinates, and we're sending them into this data set. Now the only thing here is that attributes are not being copied, but look into the X dataset, the XR dataset constructor documentation, and you'll see there's some options there where you can copy the actual attributes. But by default, it won't do that because you might have variables that have different units. So they'll, if we want to look at the actual attributes here, tmax will actually copy the attributes, but the variable itself won't have any attributes, but we can copy some of them if we wanted to, the common ones. All right, so now the next thing we're going to do is calculate the temporal mean. So with that, when I say temporal mean, I mean the mean across time. So if we have, let's say, a map for each month, and we get the temporal mean, then for each pixel we want to get the average across all time. And xarray makes it very, very simple to do this. So we're going to do this for tmax, and we use the mean method. And now we can pass the dimension, or even if we don't explicitly say dim, but we can say time, which is one of our dimensions. And you see how we get 5 and 6 in the latitude and longitude. So this value here is the mean for that specific pixel across time. And we can easily verify that. Let's say if we take, for example, you see that the shape of tmax is 885.6. So if we take all the elements for the first row and first column in the latitude longitude, you see we get all these values. So then if we take the mean, 277,98618, and you see here that, I mean, again, we have the numerics here. So we get the same value. All right, so what happens if we use the plot method? So let's copy this. We use the plot method, we get a map, and you see how we get the color bar, we get the name of the variable here, we get the axes labeled according to the dimensions and the attributes of the dimensions themselves. And depending on how we take the mean here, we can get a different type of plot. So here we have a two-dimensional array essentially, so we're going to get a 2D, a heat map. If we decided that, let's take the mean across latitude and longitude, which would give us a time series. You see, we only keep the time dimension. So if we use the plot, we're going to get a time series plot. If we just provide all the data, we can't get anything because, oops, wait, hold on. We'll get a histogram because we have three-dimensional data, so xarray doesn't really know how we want to plot this, and it will default to just using a histogram. All right, so let's go to the next exercise, which is converting the spatial mean time series to a pandas data frame. So with the spatial mean, we mean the, well, what I mean is the getting the time series, so getting the average across the latitude longitude dimension. So let's just do Tmax. Let's get it from the data, and we're going to get again the mean across the latitude, longitude. So this will give us a time series. But if we want to convert it to data frame, usually in xarray we have functions that are called to something. And in this case, it would be as simple as to data frame. And then let's just use the head method. And you see here that, again, we're getting the variable name as the column name. We get the time series as the index. And if we do describe, which is, now we're in pandas territory, so we get the statistics, we get the count, mean, standard deviation, and so forth. Then the other thing we want to do is use the SNS pair plot. That's a very nice function if you have two variables, and actually here I use the Tmax, which I shouldn't have done. So we actually need two columns. We need Tmax and Tmin. So the only thing I did is that took out the Tmax. So now we're operating on the data set itself, and you see how we're getting the Tmin, Tmax columns. Same thing here. So now if we use SNS pair plot, which let's import Seaborn first. And we'll get the Tmax histogram on this quadrant, the Tmin histogram, and then the diagonal will have the how the scatter plot of how the one variable varies with the other. So you see we're essentially getting, well, the same plot but just flipped, because in this case on the x-axis we have Tmin, on the y-axis we have Tmax, and vice versa here. All right, now let's go to the second to last part of the exercise, which is plotting the probability of freezing by month for 3 location. So first we're going to calculate the freezing probability. Now, if we have the monthly time series, we can find out when it's freezing if the minimum temperature is below 0 degrees Celsius, and because we haven't converted yet, it would be 273.15 degrees Kelvin. So that would give us, for each month, we would have a 0 value if it's not freezing, a 1 value if it's freezing. The probability would be the number of months that are freezing divided by the total number of months. However, because we're ending up with a 0 and 1 time series, we can just take the mean, because it's it's identical formula to the probability, right? Because we have the sum of 0 and 1s, which would give us the number of months that are freezing, divided by the total number of months. So we get both the mean of that 0 and 1 time series, but also that's the probability of freezing. So let's do that and name our data set freeze, our data array actually. So we have the data Tmin less than 273.15. So let's see what this gives us. So again, we see and look at the dimensions, 880, so the months, latitude, longitude. However, we want to do this per month. So what we want to get is the 12 values. So we want to group together the different months. And as you probably have guessed, we can do this by group by. Now the group by, it will use, in pandas, remember we used a column. Here it's a little bit different because we have this multi-dimensional data structures, but we can still use a group by utilizing the dimensions. So we could have said something like this, group by lat. Now we're going to use time to group by, but the nice thing about xarray is that if there is a time-stamped dimension, and we see that we have that here, you see the datetime 64ns, we can do things like time year or time month, which we need in this case. So we're grouping by the months, and we take, as we said, the mean to give us the probability. And we end up with not time anymore, but month. So we have 12 instead of 880 values, 5 and 6. And you see the values here, they look like probabilities, right? So they go from 0 to 1. So that gives us the freezing probability. Now the next part is we need to pick 3 locations. Now we could just pick, well, I want the latitude, longitude that first and first row, second column, third row, fifth column, and so forth. However, I wanted to show a different way of doing this, which is stacking some dimensions, because sometimes we need that. And by stacking some dimensions, we are combining the latitude and longitude into, let's say, a location. So let's say that we need to pass a dictionary in the stack function. So we have location, and we say, you know what, combine, we give it a list, the latitude, longitude. So this, you see now that we end up with month, but now instead of latitude, longitude, we get a location dimension, which is 5 by 6, so 30. And the reason we do this is because it will allow us to pick the 3 locations much easier by just saying I cell this time, and we're gonna pick 0 to 3 here, and there you go. So 12 months, 3 locations. And next we're gonna, after selecting 3 locations, we're gonna plot them after converting into a pandas data frame, because if we just try to plot them here, you see we get an error. But if we convert to pandas, see now we get a nice month in the index, we get the 3 columns, and we also get some information about, so we have the different, we have a multi-index for column, so you have the latitude, and then we get the 3 longitudes. So if we plot this, there it is. So again, then the thing to take away here is that how we can aggregate data in multiple ways and very flexible ways. So as with pandas, we can slice and dice our data set to get the result we need. All right, let's cover the last part, which is get the Tmax monthly anomalies and plot them. Monthly anomalies, we will plot the spatial average, and then a map as well. So first of all, we're going to calculate the data, the monthly anomalies. So we have the Tmax, and this is, again, we want to get the spatial average. So what we're going to do is, again, we want to get for each month, we want to subtract the long-term average, and then we want to get the spatial map of that. So we're going to just take for each month we're going to get a separate map. So but first let's take a look at the just the monthly anomalies as a time series, so averaging over the entire set of grid pixels. So we've got the Tmax here, and there's a couple of different ways you can calculate the monthly anomalies. So what we can do is we can say just subtract the the mean across time. So you see now we're getting, well, negative values, so we're getting the anomalies here. And then what we can do is we can group, typo here, group by time, month, and take the mean of the anomalies. So now you see how we get 12, 5, 6. And then if we take the spatial mean of that, long, we're just getting 12 values. So what do we do here? We calculate the anomalies by subtracting the long-term average from each month, then taking the average per month. So we're getting a single value per 12, then taking the spatial average of that and plotting it. And here's our average monthly anomalies for Tmax. Again, there's different ways you can do this. For example, we can just do, let's say, an entire time series. But that's not very informative. As you can see here, we have a long-term time series. So hence why I wanted to see what happens when you just do the average anomalies. And then the thing we can do also is we can look at the spatial plot. So let's just get these 12. But you see we get now 12, instead of 12 values, we get 12 maps. And let's plot this, but now let's use some keywords. And because we have 12, how about we arrange this in a grid? If we were just using matplotlib, we would say, oh, well, let me just create the figure layout and then put each map on a separate one. But xarray or all these modules just make our lives easier. So what we're going to use is the keyword column. And with that, we can say, which dimension do you want me to use to separate out the different maps? So we're going to use month, and we're also going to wrap the columns at 3. So, oops. So we're going to get a 4 by 3. And there it is. So we got a 4 by 3. If we do wrap it in 4, you can guess what we're going to get, a 3 by 4. And now you get again the different labels. So month 1, month 2, month 3, and so forth. We get the common color bar because it's the same variable. And our axes are labeled, but only in the places where it makes sense, right? Only on the outer edges of our plot. Again, back in the old days, to create this, it would take a lot more than just one line of code, but that's what it is, and hopefully this made sense. Yeah, you will get you excited to explore more of xarray, as it is one of the really great libraries for the type of work that we do.